Okay, so let's add an example of the kind of equation we've been talking about. So for example, let's look at y double prime plus 6y prime plus 10y equals 0. Okay, that's a second order constant coefficient homogeneous equation. So we can use this method. And remember, we're thinking through the idea that y is equal to e to the lambda t. So every time you differentiate y, you get a power of lambda. And each one of those terms would have a common factor of e to the lambda t. So and you could factor that out and then divide by it because it's never 0. So the bottom line is, when you see an equation like this and you recognize constant coefficient, homogeneous second order equation, we replace derivatives by powers of lambda. So this will be a lambda squared plus a 6 lambda plus 10 equals 0. So second derivative, second power of lambda. First derivative, first power of lambda. 0th derivative, 0th power of lambda. Okay. And now you want to solve that quadratic equation to tell you the form of your solution. So when we do that, I won't try to factor it because I know how this one's going to come out. So this will be minus 6 plus or minus the square root of 36 minus 4 times 10 times 1. So that's minus 40 all over 2 times 1. So that is minus 3 plus or minus the square root of minus 4i. Minus 4, jumping ahead, all over 2. And the square root of minus 4, I can write as 2 times I. And 2i divided by 2 just gives me an I. So I get a minus 3 plus I. Okay, plus or minus I, sorry. Forgot the minus. Okay, so lambda, it's a little unclear there. Let me write it right over here. Minus 3 plus or minus I. So there are 2 equivalent ways I could write this solution. Now I'm ready to write down the solution. I could write it as, one way, and I imagine this is the way that, WebAssign is going to want it. You write it as y of x is e to the minus 3x. So that's taking the real part of this thing, and that's part of the exponential. And then that gets multiplied by C1 cosine. The coefficient of I is 1. So we get 1 x plus C2 sine 1x. Okay, that's one way to write the solution. Another equivalent way is to say, okay, sorry for the interruption. So let's see, another way, equivalent way you could write this solution is you just use the complex exponential. So this is e to the minus 3 plus I x times a C1 plus a C2 e to the minus 3 minus I times x. And notice, I can write it like that. I can write it as e to the minus 3ix times C1 e to the ix plus C2 e to the minus ix. That's also a perfectly good way to write the solution. And the C1 and the C2 here are definitely not the same as the C1 and the C2 there. They're different ways to write, different but equivalent ways to write the solution. In general, in engineering and applied problems, people generally like to write it as sines and cosines because they have something against complex exponentials. But for a math person, this form is just as good as the other. Okay, so that's an example of where you get 2 complex conjugate roots. Bye.